All right, guys, the final video on strengthening undergraduate statistics. What I want to look at now is correlation because it is very closely tied to applied linear regression. We're going to learn the rest of the semester. Correlation is a technique that can be used to measure the strength of the relationship between two quantitative variables, x and y. Important notation. Whether we're dealing with a sample or a population, just as with, if you want to think here, think about for a sample mean we had x bar, and for a population mean we have mu. Well, the same notation, or at least um, the same kind of strategy, if you will, uh, applies for a sample correlation. Notation is R. In a population correlation, the notation is rho. So using IQ read, let's examine the strength of the relationship between the variables read and IQ. So just an FYI, in moving forward, there are three ways that we're going to find out to test for a significant, and again, what does significant mean? Our p-value is less than our alpha. So there are three ways, um, to test for a significant linear relationship between two quantitative variables. First of all, t-test for slope. We'll learn that, I think, in lesson 3. ANOVA for regression. I think we learned that in lesson 4. And t-test for correlation. We learned that in this video. So let me see if we can make that a little bit clearer. All right, gang, let's go get the data and get it into R. So you can see on the on my desktop, I have read IQ read. It's in .xls. I need to change that to .csv. All right, so let's do a save as. Guys, I like to name my data set something with just one word, or actually no spaces. So I'm going to call this IQ read with no space. And then I need to come down, as I demonstrated in a couple of videos ago, I need .csv, which would be comma separated values. Want to save it? You want to keep that format. And now let's get that data into R. I'll tell you what, I'm going to go ahead and close this down because I'm not going to need it anymore. All right, so I want to set the working directory. So the first thing I would do is probably get the working directory. So to set it, let's set it for desktop because that's where my data is. Next thing I want to do is go get my data. And I've named it the data set IQ read with no space, and hit enter. So we don't want to see any red stuff pop up. We want to see no response. That means that it's executed it correctly. So I need to attach my data, and I always like to do names data because that'll give me the variables in the data set. Now, the very first thing I want to do is I want to, well, I'll tell you what, I want to go back to this. Kind of have a hard time staying on task here for some reason. So first of all, when we think about calculating a p-value, we have to talk about the probability distribution, as I talked about in a previous video. So for a correlation coefficient, R, we use the t-distribution. But this time we use a t-distribution with degrees of freedom n minus 2. So we take our sample size and subtract 2. Now, why 2? Well, because we use two estimates, B0 and B1, the slope and the intercept, which you're going to learn far more than you probably ever care to learn later in the class. Next question, what's the test statistic? Well, the test statistic is to take the correlation coefficient times the square root of the quantity n minus 2 divided by the denominator. All right, so let's do that. So to make this calculation, we need to find the value for the correlation. So to do that, I can jump into R, maybe. And I can do correlation read IQ. So the correlation here is 0.525. And you can see that I have given the correlation there is 0.525. Next part of it's plug and chug, stuff we should all be easy, or very, very, very good at. So 0.525. Sample size is, this is not correct. What is our sample size? Messed up there. So I can find my sample size by doing length of either one of the variables. So my sample size is 30. So gang, that should have been 30 instead of 30 minus 2 instead of 3 minus 2, or 5 minus 2. So I need to recalculate the value here. I'm going to grab my calculator. So we have 0.525 times square root of 28. Divided by the square root of 1 minus 0.525 quantity squared. You guys, I get 3.26 as the test statistic. Now, that makes everything wrong over here. So I have 3.26 and negative 3.26. So I'm going to focus on finding this area. So guys, I'm using the t-distribution, degrees of freedom 28. So I'm going to use PT, negative 3.26, degrees of freedom 28. So I get a area in the left. Actually, I did that incorrect. This is actually the area that I just found. So I have to multiply it by 2. So I get 0.0029. So we have statistical significance. So we can assume a linear relationship between read and IQ. So guys, remember these values. The test statistic was equal to 3.26, and our p-value was equal to 0.0029. So keep that in mind. Now, as you might imagine, there's a way that we can do this with R. R is very powerful, especially very simple things like this. And what we can do is we can run let's do a model, and let's run a core.test. And I want to run this over read IQ. And then I want to run the summary of the model. Actually, I don't. I just want to run the model. And what you can see is the values 3.25 or 2653, degrees of freedom 28. And you can see that our p-value is 0.0029. Now, if we were to run the confidence interval, we can see that it would run from 0.20 to 0.74. What's important there is to notice that your confidence interval does not contain 0. If your confidence interval contains 0, then you cannot reject the fact reject the claim that rho is equal to 0. So guys, in a two-tailed test, important stuff. I know it's easy to get distracted. It's easy to kind of blank out. Huge stuff here. If you have a statistical significance at a two-tailed test, two-tailed means that your alternative hypothesis is not equal to. If you have if you have statistical significance for a two-tailed test, your 95% confidence interval will not contain 0. So a classic kind of test question may be, it's going to be kind of harder than this, but let's say I give you a 95% confidence interval for rho to be negative 0.76 to 0.52. Notice that this interval contains 0. Therefore, our p-value would be greater than or equal to 0.05. So, guys, that's all I got. Simple video. This is the video that will end lesson 1. Take care.